Okay, I'm back. This is our second example. We're still in chapter 6, section 5. And we're given this image here. We need to determine if the conclusion is valid. If not, we need to tell what additional information is needed in order to make it valid. They tell us that EF is congruent to FG, EF is congruent to FG, and they also tell us that EG is perpendicular to FH. EG is perpendicular to FH. So we know that these two sides are congruent, and we know that this intersects at a 90-degree angle. I want you to determine for yourself if you think this is valid, and then go ahead and push play again to see if you were right. So hopefully you decided that this was not enough information. It's not a valid conclusion. There are two theorems that we just learned that said that if two consecutive sides are congruent, then it's a rhombus, and there's also a theorem that you learned that said if the diagonals intersect at 90-degree angles, then it's a rhombus. But both of those theorems had to start out by saying that this was a parallelogram, and it never told you that this shape here was a parallelogram, so you don't have enough information. Alright, example 3a. We need to tell whether or not this is a rectangle, rhombus, or square. We have to check all of them. So they gave us these 4 points, and they're graphed here. That's always going to be your first step whenever you have ordered pairs, is to graph them. So I'm going to go ahead and label this. It's already been graphed for me. Point P is -1, +4, so P is here. Point Q is 2, 6, so to the right 2, up 6, that's Q. R is 4, 3, 4, 3, and S is 1, 1, so this is S down here. Go ahead and pause the video, graph it for yourself, and see if you can determine whether or not it's a rectangle, a rhombus, or a square, and then push play and see if your ideas were right. Alright, so we're going to start by checking to see if this is a rectangle. In order to see if it's a rectangle, I need to know that the diagonals are congruent. So I'm going to use the distance formula, and I'm going to check PR. So first we're going to see if it's a rectangle. PR distance formula, I'm going to take the square root of 4 minus a -1 squared plus the square root. Oh, this is not two separate square roots. I don't know why I did that. We're going to pretend that that's not there. I'm going to rewrite the whole thing. So we've got PR. We're going to subtract 4 and -1. Plus 3 minus 4. And if you work out the math, that ends up being the square root of 26. I'm also going to find the distance from Q to S to see if that's the same. QS, again plugging it into the distance formula, is going to be 1 minus 2 squared plus 1 minus 6 squared, and if you do the math, you're going to end up getting the square root of 26. And again, these points came from those ordered pairs that we graphed in that section. So because both of them ended up having congruent diagonals, then we can say that yes, it is a rectangle. Next, we're going to check to see if it's a rhombus. And in order for it to be a rhombus, we need to know that the diagonals intersect at a 90-degree angle. So we need to check if they're perpendicular. And the way that you check if something is perpendicular when you know the slopes is that they are opposite reciprocals. So when you multiply them together, they need to equal a -1. So the slope of PR, same thing, we're going with diagonals again. The slope is going to be the change in y over the change in x. So that's going to be 3 minus 4 over 4 minus a negative 1. Whoops, 4. We're going to do that again. 3 minus 4 over 4 minus a negative 1. And if I subtract those, I end up getting a negative 1/5. So that's our PR. We also need to check the slope for QS. Again, the change in y over the change in x, so that's 1 minus 6 over 1 minus 2, which ends up giving me a positive 5. And because negative 1/5 and positive 5 are opposite reciprocals, I know that it intersects at a 90-degree angle, so I know that yes, it is a rhombus. And in order to see if something is a square, it has to be both a rectangle and a rhombus. And we just found out that it is both a rectangle and a rhombus, so I know that yes, it is also a square. Alright, last one. We need to use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square again, and give all the names that apply. So again, it's been graphed for you. I have W, X, Y, and Z that I'm going to label now. W is 0, 1, so this is W here. X is 4, 2, 4, 2, that's X. Y is 3, negative 2, so 3, negative 2, this one down here is Y. And Z is negative 1, negative 3. Again, notice that it names the parallelogram in order. Alright, so we need to figure out if this is a rectangle. And if you remember on the last example, the way that we did that is we used the distance formula to check to see if the diagonals were the same. Obviously they're not going to be, but we need to prove what we see. We can't just say that they don't look the same. So we're going to start with WY. And that's going to be the square root of 3 minus 0 squared plus a negative 2 minus 1 squared. And if you subtract and then square them and then add them together, you're going to end up getting 3 root 2. And if you don't remember how to rationalize roots, we can talk about that tomorrow in class. So that's WY. Then we also need to find XZ. And just so you know, if you're doing a problem like this and you can't rationalize the root, you can leave the whole thing underneath the root before it gets simplified. You just need to make sure that they match. So we're going to find XZ now, which is going to be the square root of negative 1 minus 4 squared plus negative 3 minus 2 squared. And if you work that out, that ends up being 5 root 2. So our diagonals don't match. We know that this is not a rectangle. We need to check if it's rhombus. So in order to check if it's a rhombus, we need to know that our diagonals are intersecting at a 90-degree angle. So we need to find the slopes of the diagonals. Finding the slope of WY is going to be the change in y over the change in x, so that's negative 2 minus 1 over 3 minus 0, which gives me a negative 1. And then the slope of xz is negative 3 minus 2 over a negative 1 minus 4, which gives me, again, a negative 1. Oh, nope, this is a positive one because it's a negative. It ends up being a negative 5 over a negative 5. And a negative divided by a negative gave me that positive. So this is a positive one. Alright, so I have one slope of negative 1 and one slope of a positive 1 because my slopes are opposite reciprocals. then I know that they intersect at a 90-degree angle. So yes, it is a rhombus. To determine if it's a square, it needs to be both a rectangle and a rhombus. Because it's not a rectangle, I know it's also not going to be a square. So no, it is not a square. If you have any questions, please make sure you watch the videos again. There are 2 parts, so make sure that you watch them both. If after that you still have questions, write them underneath your notes so that we can talk about them in class. Or you can post them on Edmodo, and I can answer them there.